Hello physical science student, welcome to video 4 where we're going to look at isotopes. Okay, what are isotopes? You've probably heard the word isotopes before, so you've probably got some understanding, but let's make sure that we're all on the same page and make sure that you have the understanding that we want you to have in physical science. Now we've learned about elements and how elements are defined, and they are defined by having the same number of protons, and so the atomic number on the periodic table is the number of protons. Now, however, atoms of the same element can contain different numbers of neutrons because they're also in the nucleus, but we don't use the number of neutrons to classify what element it is, but the neutrons affect the mass of the atoms. And so you can have two carbon atoms, and they will both have 6 protons because they're both carbon, but they can have differing numbers of neutrons, and these are what we call isotopes. Isotopes are the variations within an element. Isotopes have similar chemical properties because their electron structure is the same. We haven't talked about it much, but we will in the future. The electron structure around the nucleus is defined by the number of protons. So in this section we're saying that we keep the number of protons the same in an element, and so the electron structure will be the same for all isotopes of the same element. And because chemistry is all about the swapping of electrons, the chemical properties of all the isotopes of an element will be the same. So you could have carbon 12 and carbon 14, 2 isotopes of carbon, but in terms of chemistry they're identical and they're very hard to separate through chemical processes. They are, however, easier to separate through physical properties because of their different masses, and so we use things called mass spectrometers to separate the different isotopes if we were trying to study them. Now, remember our isotopic symbol that we were using? So here we have an example of some isotopes of magnesium. We've got magnesium 20, this is the mass number, this is the number of protons. So all these magnesiums all have 12 here because it has 12 protons, but you notice that their mass numbers change, and their mass numbers change because the number of neutrons changes. 12 here, 13 here, and 14 here. And how do we know the number of neutrons is changing? Well, the mass is changing, and if we subtract the atomic number from the mass number, we get the number of neutrons. So these are the 3 isotopes. Magnesium has more isotopes of itself, all having a different mass. Now, commonly we might write them in shorthand just as Mg24, and we might refer to it as Mg24, or we might refer to it as magnesium 24, or in this case magnesium 26. Just a few minutes ago I said carbon 14 and carbon 12. It's the way we talk about isotopes. Not only do we need to know what element it is, but we need to know the mass, because the mass distinguishes the different isotopes. Here we have carbon, 2 isotopes of carbon, carbon 12 and carbon 14. Now in this book they've put the symbols here instead of here. And we can do that because different textbooks do that, but our convention here in Tasmania, all the textbooks and in most Australian textbooks, is to put the values on the left hand side. Now, a question I could ask you though is how many electrons are orbiting each of these nuclei. Now, the number of electrons orbiting is determined by the number of protons, and because both of them have 6, they'll both have 6 electrons orbiting them. Now there are 3 isotopes of hydrogen, and most of the elements have a number of isotopes. Well, all the elements have a number of isotopes, some more than others. Hydrogen has 3, and they have their own name, which is somewhat unique in the world of isotopes. Most of the other atoms don't have their own names, and so the isotopes of hydrogen are protium, deuterium, and tritium. And these guys will be important in the future when we are getting most of our electricity from nuclear fusion, but we'll talk about that when we do radioactivity. And you can see here each of them has 1 yellow proton, but this one has 1 neutron and this one has 2 neutrons. How many electrons would be orbiting around this? Well, if they are neutral atoms, they would each have 1 electron to charge balance the proton, and so they'd each have 1 electron. And here's a diagram showing you that 1 electron whizzing around, and these 3 are variations on carbon, and you notice that some are referred to as stable and some are referred to as unstable radioactive, and we'll look at that when we do radioactivity, which is actually the next topic we do after atomic structure. So here's a couple of questions that are pretty typical that relate to isotopes. The nucleus of an atom contains 19 protons and 20 neutrons. Write the isotropic symbol for the element, and if we just did that quickly over here or over here, let's see, 19 protons, well that gives us a 19 there. Looking at the periodic table, we see that element, I think I just got an email, we have, or someone else in the room got an email, did you hear that? Maybe. Is 19 tells us it's potassium, and of course we've got 20 neutrons. We don't write 20 there, we add the 20 and the 19 and we have 39. So what is the value for Z? 19. What is the value for A? The atomic mass is 39. How many electrons does it have? It will have 19. And if I click on the mouse here, there's the answers. So you can pause and read that just to affirm that I was telling you the truth. The next question is find the number of electrons, protons and neutrons in this symbol here, which is chlorine, and we'd call it chlorine 35. Now hopefully we should be able to work that out. This number here gives us the number of protons, okay, 17. Now if we subtract 17 from 35, because this is the mass number, that will give us the number of neutrons, which will be 18, I believe, and the number of electrons will equal the number of protons, because it's neutral, there's no charge shown here. We're going to deal with what happens when there's charge shortly, and so that would be 17, and there you go. So pause that and have a read of it if you need to. You'll be asked to do these questions in class, no surprises there. There's the answers, there's some more answers, but you'll have those. And I'll also expect you to copy this table and complete this table. And there's no major tricks to it, although we've got uranium and uranium here. These are 2 isotopes of uranium. Alright. And the answers will magically appear. And you'll also be doing these questions relating to isotopes in class as well. So don't do them for homework. Wait until you get to class to do them. That way I can help you. And there's the answers as well. And in the next video we're going to look at elements and compounds. Cheerio.